Our special speaker today is Dr. Razal Ahmad. We would like to thank him for his participation. Before we get started, let me give you a brief introduction about Dr. Ahmed. He is currently CEO of Nano Malaysia, and also he serves as a chairman of Advanced Materials Investment Advisory Panel Working Group under Malaysian Investment Development Authority. He holds a PhD in Nanotechnology, Electronic and Electrical Engineering from London Center for Nanotechnology. So, Dr. Ahmed, I don't want to take your time. I just leave the word to you.
Thank you very much to Sunum, the organizer, especially to Gamze for that kind introduction. And I'm honored here to be given the opportunity to share my views on the subject matter. The topic of my webinar today would be on developing and commercializing nanotechnology via international collaborations. Because in light of today's pandemic circumstances, no country or no organization can stand alone. So collaborations is key to ensure that there is a sustainable opportunity for us to grow together. So I'm proud also to announce that we are partnering with Sunum for a long-term view towards developing and commercializing nanotechnology on mutual areas of interest to both Turkey as a whole and Malaysia as a whole as well. So allow me to proceed with my presentation today. So a brief introduction about who Nano Malaysia is. So we were incorporated almost 10 years ago. In fact, this year will be our 10th year anniversary come 1st August. We were incorporated 1st August in 2011. So we have done quite a few things for the past 10 years for us to share some of our experiences in terms of connecting with the global players to complete the whole value chain when it comes to pushing nanotechnology to the market. So Nano Malaysia is representing the government of Malaysia, given the mandate from the top view to lead the commercialization of nanotechnology. So we're looking at developing the whole ecosystem, understanding what the university have done in Malaysia, looking at their R&D outputs, looking at some of their commercially viable R&D that has been completed, and how to push it to the market for eventual productization, for eventual manufacturing, so that people like you and me, wearing a different hat as a user, we are able to use nanotechnology in our daily lives. So we are also acting as a business entity. So while we are addressing the whole ecosystem development, we also adopt the concept of mutual benefits, meaning that while we are assisting universities, when we are assisting startups, assisting the small, medium businesses, also large corporations, both local and international, we are also looking at how we can also profit while we are pushing those ideas to the market. So we have configured ourselves as a business entity, growing with our partners and trusted by the government of Malaysia, focusing on building the whole nanotechnology ecosystem towards the current era, which is called the Fourth Industrial Revolution, which is a fusion of cyber-physical system, which will disrupt and recreate the way we conduct business, the way we live our lives, even the way we conduct our R&D. So this is a very interesting era. And I do believe, well, not believe, but with conviction, that nanotechnology is the primary driver of the Fourth Industrial Revolution, because without nanotechnology, you will not be seeing those high-powered processors, electronic chips, those sensors. And without those electronic systems, we won't be seeing those machine learning, artificial intelligence, let alone blockchain. So nanotechnology is the current thing. It is the era of nanotech, and we need to ensure that we understand what kind of important role that we are playing to ensure that not just our respective organization, but the whole global economy is able to reap the benefit of nanotech investment. So having said that, the background about the need for nanotechnology, aligning to the current revolution, the Fourth Industrial Revolution, clean energy revolution. So Nano Malaysia, we are positioning ourselves as a global leader in nanotechnology commercialization. So we're looking beyond our shores. Even though the name Malaysia is attached to our corporate brand, but we are representing Malaysia also in the whole global scene, going into the whole global supply and value chain. So our vision is to become a global leader in nanotech commercialization, not doing it alone, but through global partnership. So we are connecting with our friends around the world to ensure that we are able to achieve our vision, which will also benefit them as well. So we have our 4 underlying missions: energizing industries and catalyzing economic growth, deployment of and adoption of nanotechnology industry, because at the end of the day, R&D is as good as no value if it has no place in the market. As a consumer, people will start to ask questions. Okay, great R&D, but how does it benefit me as a person? I need to use all those ideas, all those technologies and systems that you have developed. And relating to that, we need to also look at sustainable business growth and development. And last but not least, we are also going beyond the sphere of nanotech, being a thought leader in terms of cutting edge technology and creating true values across all industrial sectors. And we are also focusing on our daily activities underpinned by our core values. Not only we're looking at technology, but we're looking at the human aspect of technology and the human aspect of development and human aspect of commercialization. So our core values is represented by 5 pillars: innovative, diverse, ethical, adaptive, and learning. So in short, the acronym stands for IDEAL. So this will be ideal values. We need to be innovative, always be creative, finding new solutions, thinking outside the box. Even though if you're inside the box, you need to think creatively how you can design within certain parameters. Diverse, we celebrate diversity. All ideas are accepted and celebrated. Ethical, we must have some ethical compass. Integrity is of high importance in our organization. Adaptive, COVID-19 represents an opportunity for us to pivot ourselves, to be much more robust, agile, adapting to the new environment. For example, today we're going digital. If you're looking at 2-3 years back, most likely this session will be physical, and most likely either me going to Sunam or Sunam going to Nano Malaysia for us to have this very nice seminar interacting physically with the rest of the world. But nonetheless, due to the current pandemic situation, we have to be adaptive and go on this full digital format. Lastly, but not least, will be learning. We need to always learn skills, upskilling, new knowledge, pushing the boundary of knowledge and ideas so that we are able to look beyond the horizon. What else can we do? What else can we learn in terms of benefiting the society as a whole? So a background further on Nano Malaysia is Nano Malaysia now has so-called children companies, so to speak, or subsidiaries. So Nano Malaysia is an agency facing the government, looking at how we can build a whole ecosystem, playing the developmental role, creating programs, benefiting the universities, the startups, the small, medium businesses, and also the large companies, both in Malaysia and outside Malaysia as well, because we are participating at that level, interfacing with the government, advising the government in terms of what is good in terms of cutting edge technology. That's a synergy. But below Nano Malaysia, this is where the business activities happens. Nano Commerce is our business arm or commercial arm. This is where we partner directly with our startup alliances, our small medium business partners, for us to form joint ventures. We take shareholding, we grow the business together, we provide advisory, we sit in the board to provide strategic direction for our industry partner. This is where the on the ground activities happen. We literally build the ecosystem on the ground by understanding what needs to be done in terms of getting new investment, going into new markets. This is through Nano Commerce. Our another arm, which is called Nano Verify, is our consultation and verification arm. So this entity is just as important because it provides impartial third-party validation in terms of all our technology that we have developed through our programs, which Nano Verify will be able to issue certificate of validity and authenticity in terms of whether what we have developed truly has nanotech or not. And also it authenticate and validate the advantage of nanotechnology present in terms of performance. For example, if you include certain nanomaterials into your rubber gloves, your rubber glove becomes stronger, more elastic, it has other properties or antiviral. NanoVerify is the organization to provide an unbiased, impartial third-party validation to ensure that those nanotech products that is deployed to the market will carry a logo which is recognized by the world. The third entity under Nano Malaysia is our investment arm. This is where we invest directly into companies in the form of venture capital and private equity. Now comes to the subject matter, which I think what the whole seminar or webinar is all about. We're talking about international collaborations. International collaboration is very, very crucial in this very day, especially through this very, very challenging time of which we are wading through this COVID-19 pandemic era. As you can see, an example of which how countries come together to develop vaccines. If you take example like the vaccines that developed by Pfizer BioNTech, who created it? Okay, a couple who hail originally from Turkey, worked developing the mRNA in Germany, and using Canadian nano-sized lipid as a vesicle to transport those mRNA into our body to trigger our immune response system. So that is an example of how countries come together to come up with something that is useful for the whole global nation to fight this pandemic. But not alone. The whole community, a band of countries come together under COVAX for us to have to provide some consistency and guarantee in terms of distribution of all kinds of vaccine to ensure that we are able to fight this pandemic together. And at the same time, beyond this pandemic, countries must also be in concerted manner, working together collaboratively to ensure that we are able to emerge from this pandemic and re-energize our respective economies. Because no one can stand alone in this particular case. Everyone needs to work together for us to look into the new economic era, which could be powered by nanotech. It could be powered by new energy revolution. That remains to be seen, but a lot of countries are redefining what their economy is going to appear in the next couple of years. So when it comes to collaboration, you need to have the right motivation. Okay. Why do we need to collaborate? Number one, if you meet a certain partner or prospective partner, you have to look at what are the chances of you having that shared goals, or in other words, mutual interests. You must understand if party A and party B has the same interest towards a certain nanotechnology or any kind of system or any kind of energy solution. If they see the same thing, they want the same thing, that could trigger the idea to collaborate. It's all about shared goals or shared targets with mutual interests. And parties must also have that attitude, they want to learn from each other. So that would also trigger the need to collaborate. And when you are learning, you need to contribute as well. It's all about give and take. In any collaborative project, you learn new things together. At the same time, the skill sets, the knowledge that you have earned and acquired prior to that collaboration, you contribute into it. So the concept of learning and contributing must come hand in hand together. At the same time, you look at resources. As I explained earlier, no country has everything. Like for example, China probably has the largest rare earth resources in the world. But at the same time, China is also one of the biggest producer of graphene, which is a carbon nanomaterials. Although it is not fully validated or authenticated yet, going through a certain process, but in terms of what they declare in the public, they potentially are supplying roughly about 2/3 of the graphene supply chain in the world. So they have massive resources. Some countries do not have the resources, but they have ideas. So this is also will trigger collaboration. I have what you want, you have what I want. But this is why, and this translates into creating value together, value creation. So the concept of better together, collaboratively, is key to understand why people need to collaborate. So when it comes to companies at the business level, you wish to sell your products beyond your native country or your current economy. For example, if a company from Turkey or Malaysia, we wish to have access to each other's market, we collaborate. A startup from Malaysia wishes to enter the Turkish market. A small company in Turkey wishes to enter Malaysian markets. You collaborate. You exchange your ideas, you exchange your technologies, you have mutual access. When you do that, you have speed in terms of business growth. So your company will grow faster that way because you have this partnership. I go into your market, you go into my market, your technology we share, you create something new. And this is what we call growth hacking, where you are able to expedite the growth of your business powered by this technological solution. It can be nanotech, it can be biotech, it can be green tech, but fundamentally that is what the whole idea about the need to collaboration. And once we have this in place, in your mind and in your heart, then you are ready to collaborate. So this fundamental human aspect of collaboration needs to be put in place. If there is no goodwill, there's no point in collaborating, even though there is an opportunity for you to work together, but the concept of working together must be well in place to ensure that it is a successful endeavor. So you look at the general collaboration network or delivery framework. So you need to start somewhere. So once you understand why you need to collaborate, you need to start to understand how does it take for you to arrive to the level of cooperation. So you start with coordination. So this is a loop where you need to start somewhere. So first thing, you establish what you need to do. So you coordinate. So when you coordination between partners who are willing to collaborate, this will arrange the concept of cooperation, what needs to be done. So the cooperation will happen. When you cooperate together, it demands communication. Communication is key. You must be transparent. You must communicate regularly. You must fulfill your promise to communicate. You must make it happen. And when you communicate, it generates commitment. Commitment to complete the milestones, commitment to start the project, the commitment to complete the project, which will go back to the overall coordination of cooperation and communication. But sometimes along the way, like any other individuals, organizations tend to have conflicts, especially when they communicate coming from different culture. Malaysia, Turkey, China, America, Europe. We think differently because our behavior is colored by our upbringing, our culture, our religion. So sometimes the words are not accurately expressed. That would generate conflict. But having the commitment and the coordination, you deal with the conflict so that everything comes down back to a well-coordinated cooperation, go back to communicate, and back to generating commitments, so on and so forth. Because we want to nip in the bud. We should not allow conflict to escalate because it will harm the whole idea of cooperation. So this is very critical for us to understand to make any potential collaboration work. And it'll be much more challenging when it comes to international collaboration because sometimes you cannot be physically there in the course of the project. You start somewhere, you return to your country, then you come, you travel back to your partner's location to look at or to monitor and to manage the project, but you cannot be there all the time. So vice versa. So communication is key to understand whether the project is ahead of schedule, behind schedule, or on time. If there's any issue, you need to be very open and transparent. And the concept of collaboration, there are many versions. We have to go down to the fundamentals before we go into the specific technical of how you commercialize and develop nanotech. So there are many versions here. If you can look at the mode of collaboration, we go back to the fundamentals of different versions. We have the open hierarchy on the top left, open flat, top right, closed hierarchy, bottom left, closed flat, bottom right. So what does it mean here? We start with the top left, open hierarchy. Open is when concept is you create a platform, an open platform, which allows any innovators to come on board. You state a statement. You make a statement that I want to solve a problem. I want to create a high density battery for EV. And I want to make sure that the battery contains nanotech, because nanotech will enhance the energy and power density of the battery. So all the researchers will come on board, and respond to your challenge. But since there is a hierarchy concept, the person who coordinating it will decide which of those innovation contributed by the researchers will go to the market. So there is this hierarchy concept. So there is some orchestration. If there are 100 research work in batteries to improve the power density, you as an organization coordinating the whole ecosystem will decide which of those technology or innovation will be suitable for you to commercialize. So that's concept of open by hierarchy. When it comes to open or flat, the same concept of openness, University A, B, C, D will also go into developing the same battery, the same idea about developing high energy, and high power density batteries using nanotechnology solution. But it is flat, meaning that each of those universities or research institute has equal say which product will go to the market, meaning they can decide. You give them funding, but they can go to the market on their own. Very flat, open. So based on merit, eventually they'll go to the market, investor will evaluate, and they will just deploy their product. That's concept of open and flat. But going to close or flat, which is the top, the bottom right, this is when you only allow internal researchers to conduct R&D or research or product development, responding to your statement or your problem statement, which is, I want to build or design a high energy density battery. For example, if you have 10 researchers, only 10 researchers is given that information to work on it. But since it is flat, each of those 10 researchers have the say which one of those will be pushed to the market. You give them the authority. Maybe 10 of them will hit the market. You give them all the budget, and they will just push it to the market. They can create their own spin-off. And that's the concept of closed and flat. The last version is called closed and hierarchy. This is much more autocratic, where you choose the right kind of researchers, maybe 2, 3, or 4, 5, or even 10. And as an orchestrator, organization, as the product developer, you decide which of those 10 will hit the market. So this concept needs to be understood well. The philosophy of collaboration, whether you want to have your open hierarchy, open flat, or closed hierarchy, because this will color the way you manage the project, and it will also establish the underpinning principle whether your project is partnering with the right people. So if your organization is more of an open hierarchy, you need to work with another open hierarchy organization. If you're a closed hierarchy, you cannot work with an open flat, because the culture is so different. It's very difficult for you to make a common choice towards which product you want to use, which technology you need to develop together. So this is very important for you to understand what are the qualifying criteria to ensure which partners that you need to cooperate with. Not just technological value. It's all about understanding the culture, the values, and the model that your partner is embracing. Then you're able to understand which one you need to partner with in the long run. So now comes the context of a much more technical presentation to it. Is the value and supply chain when it comes to creating this concept of collaboration work. Sorry. Okay. So there are many forms of partnership. We look at value chain, value supply chain collaboration. The version that we have seen here are many. We have seen partnership that focuses more on upstream R&D. Okay, let's do R&D together, meaning that the onset of ideation, you work together with a partner. University A will work with University B. Or industry A will work with University B, but they will start at the onset of the concept of the ideation. Very, very at the beginning of it, at the fundamental research. At the same time, you can also partner at the midstream level, at product development, meaning that you look at completed R&D, you take those technological principle, which has already been established at TRL 1, 2, and 3, you convert it into the first prototype. This is where the most industry partner will start to talk to the university. Very rarely you see industry talking to the university at upstream level, but that is what currently being encouraged by a lot of government to ensure that all R&D is being directed towards eventual commercialization. But typically you see industry starting to talk to the university at midstream level. They're looking at all, they express their problem statement, what they want to do. They look at some of those proven engineering and technological principle, and they start to create new prototype or product together with the university. Another layer of our partnership is downstream manufacturing. This tends to be a lot more commercial. This is where the university are often they don't participate at this point of time. It's more of business to business, where companies come together from partnership. It can be a local partnership, international partnership, regional partnership. This is when we look at who can start to manufacture my product. I have one prototype. I cannot produce my prototype at a large scale. You need to find a partner. Maybe the easy way out is to go to China, because China, the cost of manufacturing is cheap. So you go to China, you license your product to China. China will manufacture your nanotech product. They will start to put. So that is a form of global partnership, but it needs to be well managed, because this is where you make big money. This is where argument can take place. So you need to understand how you can cleverly put in place the right kind of terms and conditions to ensure that you are able to protect your ideas, your intellectual properties. Next form of partnership is investment and business expansion. This is when you already have an established product, an established partner, but you wish to go into another market, from Malaysia to Europe, or Malaysia to Middle East, or Malaysia to the American continent, or so on and so forth, and vice versa. You look for investment because you need cash in order for you to expand your business into those economies. This is where compromises have to be made. You have to let go of a certain portion of your business to allow for investors to come on board. This is where you dilute your shareholding. And this is also, you dilute your ownership of your technology, because when investors come on board, they want to own a certain percentage of your company. So you can form a strategic partnership so they can bring you over to their home economy or market, so on and so forth. So this is where the game of give and take. In order for me to make more money by expanding my business, you need other people's money through investment. So when the investment comes on board, you need to let go in order for you to gain more. So the ancient philosophy is, you need to empty your cup in order for you to refill your cup with water or any other kind of beverages. So that concept needs to be put in place. Otherwise, your nanotechnology ideas or any kind of technology will just sit there in your drawer on the shelf, and it will not go anywhere in terms of creating value. Another form of partnership, which is non-commercial, more of providing ideas, we call thought leadership. This is when we share ideas together. We organize conference together, we organize seminar together, workshop, for us to mix our ideas, socialize our ideas, and understanding what are the new technology that we need to develop, what kind of roadmaps you need to create, what kind of new economy opportunities that we need to identify to grow the economy. We process our ideas, we socialize, we participate in workshop, and at the end of the day, the take-home message is we take our ideas, the result of this idea socialization, and we bring back to our organization, and we work separately. This is a form of partnership, just to brainstorm ideas of how to move forward. But at the end of the day, all of this partnership, R&D, product development, manufacturing, investment, business expansion, and thought leadership, must address the triple bottom line, which is relevant to any economy, which is impacting people and planet. The triple bottom line needs to be infused into what we do, so that together we can make profit. Okay, there's no profit without people, there's no profit without planet. So mainstreaming sustainability in our R&D agenda, product development agenda, must be well incorporated, so that we are able to sustainably grow the global economy together. So once you understood the concept of collaboration, there must be clarity. So this clarity means you need to have full clarity about what kind of work, what kind of technology you want to develop, what is the role and function of each partner or partners, and how long does it take for you to complete the project in terms of collaboration. So the statement of work translate the what you want to do, SOW. This will form the core of the agreement between partners across the international borders. For example, Malaysia and Turkey, what kind of work we want to use. For example, we may have a common interest in graphene, which is a carbon nanomaterial at one-dimensional level in terms of structure. Graphene can go anywhere. It can go into tires, rubber gloves, it can go into composites, it can go into sensors, it can literally go into nano coating for any sort of applications. But we cannot do all. So partners need to agree, we need to scope the collaboration. Okay, let's focus on graphene for sensor application, because that sensor can be used for IoT application, which eventually be used for any kind of cyber physical world, smart cities, smart transportation, so on and so forth. So we scope it, statement of work. Terms of reference is what I do, what you do. Let's respect that. My job is to produce graphene. Your job is to develop the product. So when I develop my intellectual property to produce graphene, you will use my graphene to create your sensor. So that's the concept. There's a very clear thought. And once you have successfully produced the desired product, what is the role and function of each other? Should we commercialize together, or should I delegate that authority to you to commercialize on my behalf? That needs to be spelled out clearly. And when you need to finish it. Because of the urgency of the matter, you need to make sure that you have that first mover advantage in terms of deploying your nanotechnology. Timeline is critical. When? 6 months, 1 year, 18 months, or 2 years. Typically, R&D will take 3 years to complete. Product development, roughly about half of that, about 18 months. Pushing for validation and whatnot, typically about 6 months. So you need to understand what kind of work and what kind of TRL that you're at. That will translate into the timeline, the terms of reference, the role and function of each of the members of the collaborative framework, and what kind of technology you need to develop together. So I'll give you an example here. You have an idea, a product idea, which have yet to be developed. A very simple idea. I think I use the same example. I want to create a graphene-based sensor that can detect, for example, COVID-19 infected aerosol. So meaning that when you breathe out, you exhale, if you are infected by the COVID-19 virus or SARS-CoV-2, your exhale breath should contain those virus in those aerosol particles. So then in order for you to detect COVID-19 virus or SARS-CoV-2, you need nanotechnology or nanomaterial to ensure that it's able to only select that particular virus and not other viruses. Very selective. And the time to sense must be really, really quick for it to capture. So speed, selectivity, and sensitivity must be the three underlying principles of how you want to develop your SARS-CoV-2 sensor. So you have an idea. So it's all about you. You have an idea. But I don't have graphene. I don't know how to do it. I'm just an entrepreneur. I have an idea because I look at people around me, the society. I think we need this. We need this point of care sensing. So before I enter supermarket, before I enter an office building, I just exhale my breath, and the sensor will pick up whether I'm positive or not. If I'm negative, they allow me to go through. If not, they send me back home, or push me into a hospital for further diagnosis and further confirmation whether the virus is in my body or not. So you have that idea because you want to reopen the economy, because there's a lot of doubt about whether the person is negative or positive. So, but you have an idea, you don't know who can help you. So this is where you reach out. You talk to partners, because you're not you may not be an expert or holding a PhD in nanotech, but you have an idea. So you talk to partners, maybe locally, but if the local partners do not have the answer to your needs, then you reach out to the international partners. You talk to, for example, universities around the world. Okay, for example, in this case, I do example of Sunom, which is our partner. Okay, Sunom, do you have an expertise in sensor? Do you have what it takes to produce graphene? Okay, then the discussion will take place. Then if Sunom does not have the facility to produce graphene, it's fine. You look for partners who can supply the graphene to you. For example, in this case, like Abalonix, Avanza, Haydale. These are one of those entities around the world that is able to produce graphene or become part of the supply chain. They can also offer services to develop your product, but at the end of the day, you need a dedicated team, preferably maybe at a university, to translate your idea into a product which you have envisioned. And this is where the partnership comes into play, where I want what you want, and I'm able to serve what you need through this complementary need, through mutual understanding. So you have identified the scope, you identified the role and function, who can produce graphene, who can develop the sensor, but the original idea belongs to you. So these convergence of partners needs to be captured in a legal document. What is your role? What's my role? What is the end goal? And how long does it take for us to finish this project? At the end of the day, then you discuss. So therefore, we need $500,000 US to complete this. Great. So that's the budget. And you translate into an international partnership that endeavors into the product development project, which will serve a certain market need because you saw and observed the need. So, for example, Abalonix or Avanzari will produce the nanomaterial. Sunom will develop the intellectual property, but a company in Malaysia developed the idea. So therefore, the arrangement about who owns the intellectual properties need to be put in place, because the person who is he developed the original idea most likely has the money to invest. He or she will talk to investors, to grant authorities, or to angel investors, or even venture cap, and to finance the project. So this is the concept of how an international partnership can take place through mutual understanding and clarity of the work. That is a product development. But now comes where you start to make money. When you start to make money, you have to look for different partners, because you cannot work within university alone to push a product, because their role is within a certain sphere or certain position in the innovation value chain. Their work is to develop product. So you as a company or an entrepreneur or technopreneur, you have that idea. But in order for you to translate the product or prototype into something which can be used by the user or the consumer, there's a lot of things you need to do. You need to validate the product. You need to test it. And you need to work with the relevant authorities in your economy or international community to conform to a certain standard. So standardization certificate is key for you to before you push the product to the market. So you need to validate your product, collect data. So you need partners to do that. And since you are targeting not just a local market, you need to partner with national players as well on the different standard and processes. Once you have validated your technology and product, the investors will come in. The private equities, the banks will offer you financing because your product has been fully validated, accepted by the end user with all the data. And there is a demand. So they will look at all this information. Okay, I will put in money in you, and I will take some equity because that in exchange of the investment, or it can just simply a loan. So it depends on the appetite. Alternatively, you go into joint ventures through identification of a similar organization like yourself in other economy domain. For example, I give you an example here, like entities like Nano Canada, Nano Next NL, RAS Nano, Asian Nano Forum, Nanotechnology Business Creation Initiative, which is in Japan, Nanopolis in China, the Taiwan and Nanotechnology Industrial Development Association, even Sunom, all of these entities represent their respective economic domain or region in terms of developing their own ecosystem. So they have information in understanding which company is suited for you to form partnership with for you to deploy your product to the market. Because, for example, if I want to push my nanotech sensor into Turkey, I would talk to most likely Sunom, who has information about the local ecosystem, and they will probably provide me information about, okay, there's a company X in Turkey who knows about sensors, and they have pre-captured market, and they know how to test, certify your product. So you are able to work with them, form joint ventures, this partnership, and you can deploy your product faster that way. So this will involve technology transfer, investment, validation. Now, once you have secured enough funds, you need to go into manufacturing. So typically, right now, by default, there are certain countries in the world that is home to mass manufacturing. Typically China, now Vietnam is catching up because they have the cost of goods and services, or to produce goods and services is relatively lower compared to the rest of the world. So if you're thinking of going to China, you talk to a nanotech authority or a product manufacturing authority there as your partner before that entity is able to connect you with the right manufacturer who can actually to manufacture your sensor. You cannot just simply just throw your sensor to any manufacturer. You must find a manufacturer who knows how to manufacture your sensor, all the way understanding how to produce graphene as well to form the supply chain. So it's quite a complex process in order for you, before you can start to deploy your product in the market. And of course, equally important, certification. I mentioned earlier about verification, the authenticity of your product, verification of the performance advantage. Why are we using graphene sensor over a normal sensor? We go back to the original value proposition, which is a nanotech component is able to provide faster detection speed. You can only detect what you want, which is very selective. I want to detect only SARS-CoV-2 virus, which causes the COVID-19 disease. And of course, it needs to be sensitive. It can detect at the lowest concentration of the virus. So you're able to provide any preventive measure. Even one single 2 or 3 virus, it can be able to detect high sensitivity, selectivity, and speed, the original core value. So that will translate into that certification process, which will validate that your graphene sensor has an advantage over the standard sensor. So at the end of the day, you want to have market access for your product deployment. This is where you talk to all these entities that represent their respective economy. Asian Nano Forum, looking at the whole stretch of Asia, RAS Nano for Russia, and NBCI for Japan, Nanopoly for China, Sunom like for Turkey, Tanida for Taiwan, NanoNext NL for Netherlands, and Nano Canada. So this is just an example of the nanotechnology partners in the international global scene for who you can partner with, so they can connect you with the right kind of manufacturer, investor, or even a company that is similar to your size. So this is the concept of how you can successfully commercialize your idea into something which is tangible that can be used at the end of the day to deploy in the market. But going back, once you understand the whole concept, we also need to look at once you start to pre-identify what kind of project you want to use, the scope, what technology you want to commercialize, what kind of market area you want to go to, we take a step backwards a bit about how do you execute your collaboration project. Typically, before COVID-19 era, we always meet physically, regardless of our locality or location in the world. So this is where partners physically work together, or partners physically working together. They have a shared goal. They design their milestones, what needs to be achieved. In our example previously, is this graphene-based sensor to detect SARS-CoV-2, for example. So all milestones are well clearly defined. You have a timeline to complete the project within 18 months, or maybe 6 months, depending on the TRL, technology readiness level. So this is the way of the old way to doing things. For example, I may send researchers to Turkey, or Turkey may send researchers to Malaysia to develop the product together. So that is something that needs to be discussed. So typically the combination of working together tends to be physical. But COVID-19 somehow forced us to work creatively and differently, for which we can still partner, collaborate remotely, but well coordinated by working together, aligning our shared goals, meaning that researchers in Turkey and the researchers in Malaysia will have very similar milestone to work with in parallel, complementary to each other. Going back to the previous example, for example, Malaysia developed the technology to produce high quality graphene, which is electronic grade to sense SARS-CoV-2. Turkey, on the other hand, will look at how you use that graphene and design a sensor around it to form that complete value chain. One is raw material production, one is developing sensor. Then once the sensor has been developed, it may be returned back to Malaysia to complete the whole system, the sensor system, packaging it. Because I do believe Malaysia is also one of the biggest electrical electronic hubs in the world. I think that the electrical electronic sector contributes 33% of our export value. So there is some competency in Malaysia to create the whole electronic system. So production of raw materials in Malaysia, developing the sensor in Turkey, and completing the whole end product in Malaysia. And once the product has been fully developed and systemized, and both entities, the Malaysian entities and the Turkish entity, will agree, okay, we will have to agree that both parties have the right to commercialize. So Malaysia have the right to commercialize in this region, Asia Pacific. Turkey has the right to commercialize maybe in the Middle Eastern area. If you want to go to Europe, we form a joint venture partnership. Those are the concepts that will put in place a successful collaboration from the very beginning, because you need to start the end in mind. So these are the concepts that we need to establish at the very beginning of any collaboration, so that the end goal is always towards commercialization. So any endeavor in nanotech or any other advanced material or any kind of technology has a way to reach the market, which is what everybody wants. So to share with you what we do in Malaysia. So we have a program that we have put in place for the past 5 years, and we also have successfully secured the Malaysian government's approval to continue our program in developing the nanotech ecosystem. So what we do here, or what we are undertaking in Malaysia, is we receive project investment funds from the government. We call it development expenditure funds, where every year we're being allocated a certain fund by the government of Malaysia for us to activate projects. But our projects investment here has a certain prerequisites. We need to work with the local universities or foreign, and we need to partner with a company, because the company needs to be pre-identified as potential off-taker for us to carry the technology all the way to the market. So when the statement is clear, the problem statement has been clarified and made clearly, we look at compatible partners from the universities for us to work with the industry. So this is where the university is able to provide technology consultancy and R&D facilities, whereas the industry will provide what they need, the problem statement. So going back to the earlier example, I want to create the SARS-CoV-2 sensor. And the industry needs to also invest something like their asset, their people, their previous technology. So together, we create two versions of projects. Call it product development, if it hasn't been produced or developed yet, or if a prototype has been pre-developed, we scale it up to produce to a certain extent. So for example, a project to produce, instead of just one sensor, we invest in a project that allows the company to working with the university to produce maybe 100 sensors. We call it a pilot production scale before we hit the market. This is where, in the context of this congregation of players, we have Nano Malaysia as an agency represent the government. We have partners from the industry and university. This is where international players can also come on board to provide technology consultants and R&D to local players in Malaysia. Normally, we will do domestic scanning. Is there a player or researchers in Malaysia that is able to assist our industry partner or us? If there is none, we will look across the globe. Who in the world or around the world is able to provide us the relevant technological assistance to develop a product? So the examples I've given you previously, we worked with companies from the UK, from Sweden, from some parts in Europe, in Spain as well. They provide technology consultancy of which the local researchers are unable to provide because of the uniqueness of the statement. And this is where we open up our doors to get international participation to interface with our local startups and our small businesses to develop a certain product that is useful for the company to push it to the market. So the output of this product is we develop new patent or new IPR that will eventually come in the form of product that can be fully commercialized. And we form joint ventures and partnership with the local industry players. Or we can even create new companies together with them, which also answer to the national agenda in creating new entrepreneurship opportunities for local, for the citizens in Malaysia. So while we are pushing it through, this innovation from the university working with industry, with the university or local or foreign provide the technology consultancy and R&D support. The industry will form the business vehicle to commercialize. New products have been developed. Production is also being assisted. New patents are being filed. New products are being produced, and new ventures are being created. Those nanotechnology products will need to be eventually certified. So hence we put our Nano Verify program as the final check gate to ensure that the nanotechnology idea will persist throughout the process at the prototype level and at the manufacturing level. The nanotechnology component survives and it will still provide the technological performance, economical advantage as how it was ideated from the very beginning. So when we push the product together, there is a return on investment. This return on investment shall be shared between our partners, typically with the industry partner. The university have a choice. They will receive their reward as a technical consultant from the very beginning. But when they receive their reward, they have no claims over the IP because they are being paid for. We call it work for hire. If the university decided that they want to participate all the way through until commercialization, they need to provide some level of contribution, meaning that if they could also provide their technical expertise, advisory, R&D support without any kind of payment, then we will accommodate their request to take some equity into the technology, equity into the business. So they will also be our partner in terms of commercializing the nanotechnology-based product into the market. So the university will have their share in terms of their profits. The industry partner will have their share into the profits. And us, Nano Malaysia, as a business entity, through our business arm, Nano Commerce, will have a certain share. So the percentage or the equity breakdown will differ or variably change depending on the contribution by all parties. For example, if Nano Malaysia puts ringgit 1 million or $1 million, the university will put a certain X amount. industry will put X amount. So we put everything in consideration, and we agree to a equity or shareholding structure, how much will own what, who will own how much, and that will translate into how much profit of these partners will be able to recoup based on their early investment. So this is the concept. But having this framework is just as critical in understanding which area you want to work with. For Malaysia, we have put a certain specific focus in terms of interest, because Malaysia focuses on food, agriculture, electronics, energy, environment, and healthcare. These are our 4 primary strategic sectors that is deemed to be strategic for nanotechnology deployment. Because in food and agriculture, we have plenty of nanotechnology opportunities, fertilizers, those Internet of Nano things or nano sensors to detect the health of the growth rate, the quality of water, so on and so forth. Electronics, the sensor itself, the electronic devices, the processor. For energy environment, I give an example of the battery technology, solar panels, that is now in the 3rd generation where you use advanced material other than silicon, using nanomaterial to improve the efficiency of conversion of solar energy into electricity. Healthcare, I don't think we need to go too far into, for example, we have the COVID-19 vaccine developed by Pfizer BioNTech is supported by nanotechnology. mRNA itself is at nanoscale. The nanolipid itself, by the name itself, is at nanoscale to carry those mRNA into our body to trigger our immune response system. So this is the focus area at the macroeconomics level. But when you go down to partnership, you need to be focused on what kind of technology, what kind of product that you need to use. And identifying the right kind of partnership, going back to my previous slide, whether it is open hierarchy, closed hierarchy, open flat, or closed flat. Because partnering with the right collaborator is just as important as the technology itself. If your partner does not have similar model or similar philosophy, collaboration, be it domestic or international, can be really, really challenging. So you need to arrive or land on the same page to ensure that everything is clear, the scope in terms of statement of work, the term of reference, who does what, and when. When do you expect to complete the projects? And everything here will translate into how much money you invest into the project to ensure that your nanotechnology idea is be able to be diffused, incorporated, and deployed to the market effectively. Because nanotechnology, it covers almost everything that we have seen and observed and feel. The 4 jumpstart sectors that we have shown here is just our focus area, but it goes beyond this. You can go even textile industry, wastewater management, circular economy, so on and so forth. But for Malaysia, being a relatively small economy with 33 million people in terms of population, we need to focus so that we are able to manage our resources. And there is also one of the key elements for us to partner with our partners. Our partners need to understand our strengths, our weaknesses, and understanding also all the opportunities and threats that we are facing in activating the right kind of project that we can work together. So with that, I conclude my webinar session to understand at a high level how organizations can work together. So the take-home message is very clear. Understand what you want to achieve, understand who you want to partner with, understand what kind of nanotechnology or any technology you want to work with, understand the timeline you need to focus on to complete the project, and be able to understand how much money you want to put in. With all of those key elements put together, working with an international partner becomes less challenging and workable, both in the short term, medium, and long term. So with that, thank you for your undivided attention, and over back to you, to Gamze.
Thank you, Dr. Razal. Thank you for this inspiring presentation and for your time. As you mentioned, collaboration is the keyword of these days, especially. And we believe that Nano Malaysia and Sunum collaboration will have a highly impact on nanotechnology ecosystem. So thank you for your time. I just want to ask to participants if there are any questions or any additional comments you would like to add. I think we don't have. And I also want to thank to our participants as well. Thank you.
Okay.
Thank you. Bye-bye.
Thank you. Bye-bye. Thank you. Have a nice day and stay safe, everyone.
You too. Bye-bye.
Bye-bye.